Good afternoon, everyone. The House of Sultan and Sons Private Limited and methodAI extend a very warm welcome to all the participants of today's Artificial Intelligence webinar. It feels nice to have you all here, and we thank you for that. A bit about the House of Sultan first. Pioneers in the field of book publishing in post-independent India, we cater to students from pre-primary to university level, churning out over 600 regular titles, besides adding new ones to our stable year after year. Known for competently written, elegantly produced, and reasonably priced books, our publications are widely prescribed in schools and colleges in India and in some neighboring countries as well. Our authors are distinguished academicians, professors, and educationists with vast experience and expertise. We are proud to be associated with them. I now introduce you today to the host of the webinar, Dr. Sachin Gupta. Besides authoring artificial intelligence and data science textbooks for classes 9th and 10th, Dr. Gupta is Dean, Research and Innovation, Maharaja Agrawal Institute of Technology, Guru Gobind Singh Indraprastha University, Delhi. I take pleasure in informing you that Dr. Gupta has added another feather to his cap. His latest book on AI, Decoding Artificial Intelligence, has won the Outstanding Contribution to AI Literature Award recently. A great feat indeed. Besides, Dr. Gupta has also been HOD Computer Science Engineering and MCA Department, Dronacharya Group of Institutions, Deputy Director and Head, Computer Science Department, Chandraprabhu Jain College of Higher Studies, affiliated to GGSIPU, Delhi. With a teaching experience of over 20 years, which includes teaching undergraduate students, postgraduate students, and researchers, Dr. Gupta's academic pursuits have been fairly meritorious, winning him several awards, distinctions, scholarships, including the Certificate of Academic Excellence by GGSIPU. Dr. Gupta has also contributed to various journals, conferences, and books for schools and higher education, both nationally and internationally. His achievements are truly commendable. I now request the man himself to take you through today's webinar. Dr. Sachin Gupta. Have a great day ahead. Thank you.
Thank you. Thank you so much, sir, for the introduction. This session is a continuation to what we completed 2 weeks back. We had a very brief detail into what natural language processing is, including the application areas. You are already using that in several forms when you speak to Siri or Alexa or your Google Assistants, or when you are using any large language model or any chat server, that NLP is everywhere, almost. And in fact, with generative AI, it is getting even more important, because prompt engineering is again a form of NLP, that if you want to generate an image or a video or an audio with certain specific tools or characteristics, then you need to understand how the system is going to process whatever you are saying. It's the form of a prompt, because that is human language. We also discussed several challenges of NLP, including that what to learn from. There are so many languages, there are so many dialects, there are so many sparse languages like Awadhi or some languages for which there is not much literature available to learn from. But scientists are trying to still work on that, how to increase, how to augment that data. There are now even generative AI models which are allowing you to upload a file, create data based on the prompt that you say that I want this image to be converted to black and white. They understand the NLP that way. So those things apart, as far as our class 10, 9th and 10th curriculum is concerned, we have to look at NLTK library as a very easy means of working with text data, and that we are going to take up today. In case you have any queries along the session, please feel free to post them to the chat box so that we'll be able to answer them. Uh, at the end of this session, if you want, I'll be able to share with you the complete source code for what we are discussing today so that you can use that for your processes. So just remind me at the end of the session that I need to share this file. I'll keep it open. In fact, let me try to share so that you can also work along in case you want to. I've used this on Google Colab tool for anyone who wants to work with it. I'm just posting it in the chat window for you so that you can maybe open it on your screens while you work. And that is available for all of you. So the session actually, any NLP data you will be looking at, it would be working with either audio or some transcript or a text file. So we have taken a text file here, which is specific to it from, you can take any file on the internet. You just have to use the wget command on Colab, put the link of the file and it would be imported. All right. So once the text file is imported, you will have a message from that. It would just be success. If there is an error, it would just lead to an error. And then the text file itself, we store it into our own data structure by reading using a text file dot read command. And this would be the one data that we are going to work for the remaining part of our complete workshop. So we can always see what is the type of the data that we have just imported by using the type. This is a basic Python command which works for any kind of data. You may be working with strings or numerical data. It just tells you what is the type of text you are working. So it's a class string that confirms that the data that we have imported is basically text. And then we have a printed, we try to print whatever we have imported. So it's a long text. It will not coming completely on the screen, but you'll be able to see how the text works. We have also tried to print the length of the text that it is providing to us. Fine. After having that, this is the data that we are willing to work on. You can have directly, you may simply import the text directly without bringing in a file from the internet. You may straight away store something in the form of a string directly here. You can put in double quotes, whatever text that you want to work with. The application would still work. Then the second thing that we do is we import an LTK. From NLTK, we import sentence tokenize, word tokenize, and we also download a lot of popular library that NLTK has. So when this is run, you will see that there is a lot of libraries from NLTK which are being used, because for any NLP application, you require a corpus. The corpus would be a complete set of words which NLTK has already learned, some sentences, some rules, some applications that it actually wants to work with. And once it downloads, the popular collection includes a lot of things like uh, the Project Gutenberg completely, movie reviews, then Shakespeare, then stop words. This we are going to require in our workshop today. Then WordNet for a lot of application that we use. Snowball, the stemmers, the word lemmatizers, all of those we are just simply, and at the end of it, it just returns a true. That means it has downloaded all the popular libraries which we are going to use. The first task with any NLP is that we want to break the complete text into sentences. That is a sentence tokenizer. So sentence tokenizer comes from the NLTK library. We just imported it at the beginning. So I have written from NLTK import sentence tokenizer, and I'm just using the same function over the text that we created after reading the complete source code from which would be downloaded from the net. We stored it into a variable called text, and this text variable is the one which we are using as an input. And this is subsequently for our operations we are going to use. And then sentences would contain three different or jitne bhi, any number of parts, that any number of sentences which it tokenizes the text into. So if you see the text here, I do not know in advance that how many sentences were there. So a sentence is usually characterized by a full stop. That when one full stop comes, then it considers that one sentence is complete. So I just want to find out how many sentences are there. I print the length of sentences. So there are total 9 sentences in this. And then I print the variable using the print keyword. So sentences gives you an output that this contains all of the sentences stored as single units. Each of the sentences is a single unit now that we can individually work on instead of working on the complete paragraph. The natural succession to this would be that we want to now break the sentences into words so that we'll be able to apply different operations on the word. And this is the second part of tokenization where we use the function word tokenize from NLTK again and store it into another data structure called words. How many words are there? We just simply find again the length function, and it gives you that there are total of 144 words across 9 sentences that we had, and it breaks everything into a different token, including the punctuation. So beware that every comma, every full stop, every hyphen, everything is going to take it as a word. The moment it encounters a space, it considers the next thing coming as a word. Correct. Now I wanted to check that what is the frequency distribution of each of the word that is coming in this. This is for our own analysis that we want to see what is the kind of text we are working with. What is the kind of, what is the number of punctuation marks, what is the number of uh, two-letter words or each word for each of them. So we use from NLTK.probability. This is optional that you may want to, but this we use for visualizing what is the structure of my sentence. So we take in another variable fdisk. This is going to store the frequency distribution of the words, and we pass on the output of the last command that we had, the word structure into frequency distribution. And this is going to list, you may say most common 10 words because there are total of 144 words. If we are going to see the frequency, so there would be words which would be having a single frequency also. So I'm just trying to list the most common. I'll have to run every operation down the line. So let us try to run each of these. That's what. So please do run everything when you are working with the file because it requires the previous content to be run for the next data structure to be populated. So sentence tokenizer, then tokenizing the words. Then eventually the words get populated. And I have just changed it to 1. You may want instead of 1, 15 most popular or most common words in that. It's going to give you the frequency distribution for all of them. I can take it down to 20 till the time I reach across words which are singular frequency words. So far we are getting words with frequency of at the most 9. That was a full stop. Because there were 9 sentences, logically we'll be able to conclude that 9 full stops gave us 9 different sentences. And then and, little, a, was, there are a lot of words that we can. And we try to create a plot because the frequency distribution is a number followed by every word. So this plot gives us that for each of the most common, so for dot there are 9 counts, for and there are 7 counts, and so forth. So if I plot this distribution, I would be able to see how immediately the number of words goes from 9. There was a single word, then the most commonly used would be either 4 times used or lesser. And then I create an empty list to store all the words. But I do not want to store the punctuation because punctuations are not going to give me any meaningful understanding of what interpretation to make. Punctuations are required for the sentence structure, no doubt. But when coming to NLP, there is a lot of things that we can sacrifice to make sure the computational complexity remains less. I'll elaborate on this. With machine learning, any of the algorithms that you work with, let it be data science based, let it be computer vision based, let it be NLP based, we always try to minimize the data that we are feeding for learning or for processing because we want to learn as much as we can from as little data as possible. The moment we add on more data, it leads to more computational complexity, more time taken for processing. That leads to a lot of other problems also. But for the time being, with NLP again, that we have to remove the punctuation. So for removing the punctuation marks, I am just taking a simple loop for W in words. If W dot is alpha, then we are simply appending it to the words with no punctuation and after converting it to lowercase. So if any word had a uppercase also, we are just simply taking it all to lowercase because the case also does not matter when we want to understand what is the usefulness of these words. And then we again print the total words which are there converted after the no punctuation. And we see the length reduced from 144 to 132. So all those words which were punctuation get back to this. So the commas and the full stops, they are all gone. All right. So far, so good. What we now see the frequency distribution again of words with no punctuation. And you can see that the frequency distribution is eliminating the full stop, which was coming 9 times. And our plot reduces to 7 words, which is maximum for and the remaining words are of a lesser frequency. Going on ahead, what would be the next logical step when we work with NLP is that the words which are most frequently occurring, like and the, they are again for used for giving structure to our sentences or to give that how to make the continuity of our text going. So from that, we just have to remove those words which are called stop words, that these words are not very meaningful in their own sense, but they add value to your sentences by making the continuity remain. So from these stop words, we find from the nltk.corpus. Corpus, I told you, is a huge library of whatever NLTK has learned from several languages. And from the nltk.corpus, we want to import the stop words and we want to apply only for the English language because stop words would be there in all different languages and there would be different stop words for that. We import all the stop words of the English language and print that this is the total list of all the stop words in English language which NLTK considers as stop words. So you see, I, me, my, myself, we, our, us, ourselves, you. These are considered stop words because they don't add any meaningful. I mean, they are meaningful for sure, but Understanding the semantics of a sentence, what it is trying to say, can be done even without these when it comes to NLP. So NLP is that powerful. Okay. So we have printed a list of all the stop words, and now we want to clean the text which are not in stop words from the data that we had. We had eliminated first all the punctuation, and then we are removing the stop words also with this code. So we create a clean words data structure which would store all the words which are not stop words. So from my list of 144 in the beginning, which contained all the stop words, all the punctuation mark, to now 132 without any punctuation marks. Now I am reduced to 65 words which are neither stop words nor they are uh, punctuation. So this is the set of words that we are going to work with. Correct. I hope there are no queries so far. And if we take a frequency distribution, you will be able to see that our frequency is still. So the plot goes to at the most 5 words, which is for little, then pig is across 4, and then sharply reduces to 2 characters for more than half of the data. Now, we are working with a very small data set of 144 total words, but most likely when you are going to be working with NLP, you may be working with a complete book at a time. There may be a couple of millions of words. So this reduction that you are looking at is very significant when it comes to NLP, that first removing the punctuation mark, then removing the stop words, because more than half of the data, even sometimes 70% of the data includes the stop words and the punctuation mark. So this frequency distribution plot is just to show you that how we are reducing the time complexity of our data from a very high, from 144 to 65. So you see the reduction is almost close to half. 72 would have been a middle mark. 65 is better, even better than half of the word that we have eliminated. So let us look at what we have now on the basis of this. Word cloud is a library that allows you to picture all of the words that you are looking at in the form of a word cloud, where the words with maximum frequency, they will be coming in the biggest font, like pig was very frequent. Little should have been even bigger than this. So these words which are more frequent, they would be appearing with a bigger font. The words which are less frequent, like hard or they would be or looked, they are appearing in less frequently. So frequency chart was giving you only for the 10. Maybe if I take it to the first 40 words out of 65, you see how sharply it falls down. So from 5 to 4 to 2, and this is only for the couple of words. After that, there are a lot of words with a frequency which is single. Right? That is what I am talking about, that several words would be gone from your list. And after that, there would be only a very few number of words which are appearing very repeatedly. And most of the words are like, they don't appear very repeatedly. And we can visualize this in the form of a word cloud as well. That is the next part. So you use the word cloud library, import word cloud, import matplotlib for the plotting of this graph, and then simply generate the text using the word cloud. Okay. We can even create a word cloud for a different shape, that this was rectangular. Let us suppose I wanted to store it as a circle. So again, the same issue. I use word cloud to import. I use a mask. This is coming from computer vision. Masks are the shapes on which we either want to picture something or which we want to hide something against. So we are taking a circular mask for this, and then we are simply using that mask using along with the word cloud to create a cloud of words. So you see little and pig, they are coming again the same structure as we were having earlier. And there is a very small word fireplace. Let us look at the structure where fireplace is coming. It's not even in the top 40. It is coming even after that. All right. So you get the gist of that. If we want to visualize that what data are we working with, that visualization can be in the form of a frequency distribution. That can be in the form of a word cloud. Word clouds appear more visual to anybody who wants to just simply text, and frequency distributions appear more like a statistical point of view of how the words look like. From that, we can take it forward to the basic of NLP, that's stemming. Would somebody tell me why are we using stemming and lemmatization both? Sometimes we use only stemming. Would it work with if we were to work with only lemmatization? Why not we use lemmatization? Why do we use stemming prior? This is for the audience. And there is a lot of different ways. I mean, at several different workshops, people have asked me, sir, is possible that stemming gives you different words in different contexts? So I'll share the answers to all three. First is, what is the algorithm for stemming that we are using? There are several different algorithms for stemming. More or less, they give you the similar answers, but it is not necessary. So for some algorithm, the stemming operation might result in some different word. For some other operation, the stemming result might result in a different word. So it is not necessarily standard to have the word reduced to a stem form, which is always going to be the same. For this, let us say the word list was study, studying, studies, and studied. Porter stemmer is going to reduce to study, but there may be some different algorithm which might reduce it to study, not to studi. So that may be a difference. But some people argue that why would not it convert it to stud stud? Now stud has a different connotation. So English as a language is that way a little confusing, because that itself would be a complete word in itself. So if it would have reduced it to stud, then the meaning of that word would have been changed entirely. So Porter stemmer keeps into account that there are other words also which might have a similar uh, sound, but which have a absolutely different meaning. So studi is okay, study is also okay, but stud would not be okay. So some text says that we can just eliminate the common part of all of them, including anything which is a suffix to that. That does not work. The algorithms are more complex than this for that. Then for stemming, if we want to apply it on our own work, or there are more examples that we are taking applying stemming to studies, leaves, decreases, and plays. So you see, this goes to studi, this goes to leav. Now, this is again a word which is going to be problematic because leaves may have a stem form as leaf. This might be applicable to leave, leave as a holiday or as an off that you take from your work. So that is why this would be ambiguous most of the time. If I would reduce to leaf, that does not say that this leaf is actually coming from that as a plural. So for decreases, this is just removing the es part. From the play, this is again just removing the part for a. So different algorithm may be resulting in different type of results, but the rules have to be provided by the Porter stemmer. So if you want to see the Porter stemmer algorithm, search for it, and you'd get a very big algorithm where it gives you all the rules for how is it applying the Porter stemming to different words that we have. So teachers almost every time when we are having a workshop, they ask, sir, how is it possible that the question, how do we tell the student that this is an answer that is supposed to be there for the stemming operation, because stemming is sometimes different. So I tell them that there is a problem with the questions itself. If your examiner is going to understand that these operations can result in different answers, they might not even put it. But since people are putting it still, so the best bet is that in case the student wants to understand what option as per what they have studied is the best, they can write the answer and they can explain the reason for why they have written it and which stemming algorithm they are following. That having said, uh, for our own data, okay, there is a different stemmer like snowball. For snowball stemmer, we can apply that to a word list for stemming, and this is still resulting in STUDI. So there could have been uh, a snowball stemmer works across a lot of languages. So see, it works for Arabic, Danish, Dutch, English, Finnish, French, not all, but still a good number of languages snowball stemmer works across. So it can allow you to work with Arabic characters also, German also. For each of them, the base form of the word would be different. Now, lemmatization and stemming have two different operations. First, let us understand what lemmatization is, and then we come to why we use stemming or why we use lemmatization, or should we use both, or should we use only one. So, from NLTK, we can import a WordNet lemmatizer, and if we give it a word list, it just converts them to the base form of that word. So, lemmatization is for study, it is study. For studying, it's the same. For studies, it's the same. For studied, it's the same. There is no change happening here because each of these words have their own meaning. That word has a base form, but that base form is complete. So for the remaining words like an, is, are, was, were, for all of them, the lemmatizer gives you B. So lemmatizer always has its own rules. Stemming is always having its own rules as well. So we check it across a lot of words that you can work with. For studies, the Porter stemmer gives you STUDI while the lemmatizer gives you STUDY. All right. Now, let us come to the difference between why we both of them are converting to base form. While stemming is basically based on only an algorithm that would give you the base form, there is a set of rules on the basis of which stemmer works. Lemmatization works with a dictionary check. What is the significance of both of them? Please do understand that while I'm processing my data, if I pass it on to an algorithm, the algorithm is going to be a sequence of steps which the word would pass through and finally result into a base form. This is very computationally uh, efficient for that matter because every word, whichever word we pass it on to the stemmer, it is going to take that word, convert it to base form after applying a set of rules. Lemmatization, on the other hand, is a dictionary comparison. It is going to take the word, it is going to compare it to a complete dictionary and then find out that what is the base form of this word. When it comes to machine learning, stemming operation is very cost effective. Lemmatization is very expensive because lemmatization requires you to bring in the complete corpus, compare every word with the dictionary set, and then be able to produce that this is the word which is the lemma form. Well, so sometimes when we want to apply, lemmatization is more precise, it is more concise, it is actually giving you better accuracy. Stemming is not so accurate. That also you have seen. So normally we do, if the data set is huge, if the text that we are working is very big, we first apply stemming to convert as many words as we can to the base form. Then for the remaining, we apply lemmatization. We apply both the operations. So we save some cost of that, the other word for which we could not find lemma. We can first convert them to the stemming form and then apply lemmatization. But if our text is small, we can straight away apply lemmatization without actually having to go for stemming. So that you would have to keep in mind that stemming and lemmatization are both sometimes not necessary. For a small data set, lemmatization is good enough. For a data set which is huge, we first apply stemming, then we may apply lemmatization. So for better accuracy, for that matter. I hope there are no questions till that. Okay, so there are a lot of examples that you are going to be able to check with. All right. We may also say that whether we want to have an adjective or a noun for that. From lemmatizers, okay. Check with the stemming and lemmatization. For studies, it gave you study. For leaves, it gave you leaf. For decreases, it gave you decrease. For plays, it gave you plays. Some are same, some are different. Okay. The next logical operation with NLP is part of speech tagging. Part of speech, you know, that can be noun, that can be verb, that can be adverb. So which part of the speech are we looking at? Because this would be essential to understand that what does my text contain? Is it which part is what? Because this is where the NLP is going to create a rule chart. That a verb would be usually associated with a noun, that what it is being applied to. Or if an adjective is there, then what it is actually signifying, the significance of. So we try to do a POS tagging, that is the part of speech. From the NLTK, we have a library function called POS tag, which we can apply. So studying is a verb, while study is a noun. All right. So for POS tagging, let us take an example which is bigger. A sentence goes like, a very beautiful young lady is walking on the beach. We first tokenize it into a sentence as we did prior. We then tokenize it into words as we did prior again. And then we apply the POS tag on the tokenized word. So for each of them, it gives you what part of speech does it actually talks about. All right. So you can extract the noun phrases from the text by taking a NP. Noun phrases are different from nouns. A noun phrase is something which is going to be in totality, it would be a phrase, but it works as a noun when it comes to text. So for that, beautiful young lady is a noun phrase. Instead of beautiful being a word, which was an adjective, young was an adjective, lady was a noun, a beautiful young lady would be considered as a noun phrase. So when you are reducing your text to noun phrases, that helps you to club them together and take them as a single unit, because all of them signify a single uh, opinion about that this beautiful young and lady, all of them apply to a single word. Okay. So on the beach is again going to be a noun phrase. Instead of the beach being a noun, any qualifier can be clubbed together into this. Okay. So there is then we do named entity recognition. This operation tells you that okay, named entity is still a continuing area of research where you want to see that which noun applies to, like, is it a person, is it a place, is it a country, is it an organization? What are we talking about? That gives us more information about the text that we are working on. So for instance, you have a sentence which goes like, Mr. Smith made a deal on a beach of Switzerland near WHO. So what is each of them signifying? They are not just nouns or adjectives or adverbs. They are also, they have a bigger significance than that. So Mr. Smith is basically from the tokenized words, you can apply the any.chunk operation for named entity recognition, store it to an NER and then print the NER. So person, Mr. Smith, it leads to person. Okay. Switzerland leads to a country. WHO leads to an organization. And NER keeps on evolving with time. With more organization coming, NER has to understand more with different countries, with different states. So you have to keep on training NER to understand that what is the significance of this. Here, corpus also makes a very significant contribution because normally it is through understanding of the corpus when the words keep on repeating and they have a meaning always pointing to the same entity. That is how you actually recognize the entity. Okay. Let us go further from this. You want to sometimes find out what are the synonyms or the antonyms of the popular word that you are using, right? What is the meaning? So WordNet is a library that allows you to find the synonyms or the meaning of them or the definition of a word or the examples of that word or the lemma of that word. All of them can be done using the WordNet corpus. Okay. Then how many different meanings of this word can be there? So fun can be merriment, playfulness, fun can be play and sport, fun can be playfulness. So for each of them, the lemma would be different. Then you can check it for play. The play has a different connotations. It can be a dramatic intention for of a performance by the actors. It can be play as in fun that you are playing something. So there would be different meanings of this, and WordNet can allow you to understand each of them. All right. Going further, I mean, majority of the part of NLP that you are going to cover across till class 9 would be sentence tokenization, word tokenization, lemming, stemmer. Some of it would be part of speech tagging, and maximum it would be named entity recognition. But if you want to go beyond, take your students across a journey of that how to understand that the word may have several meanings, you may want to bring in the WordNet. If you want to see what are the antonyms of a word, you may want to bring in the WordNet again. So that you can use from this library or this workshop file. So you may find antonyms. Again, create an empty space, take the word, and if lemma.antonyms are available, then store of them. So for natural, unnatural, or artificial, or supernatural, or sharp, they are considered to be antonyms. If you want to follow antonyms and synonyms both for a single word like new, you can again use this practice. So for new, fresh, novel, raw, unexampled, newfangled, there are a lot of words which are considered to be synonyms, and old and worn are considered to be antonyms for this. Now, this would be again dictionary specific. For some dictionaries, it may be different. For some other dictionary, they may be containing less. So WordNet is kind of a dictionary for you, which is going to allow you to understand that these are the synonyms, these are the antonyms as per WordNet. For Oxford, they may be different. For Britannica, they may be different. Now, why we did this was because that with ChatGPT or with any other chatbot, sometimes it has to understand that some word has been said, but that word may have a similar meaning to some other word, or how are these words related? So, similarity in words is one popular operation that we require, like ship and boat. They are two different words. They have absolutely two different meanings. But when we check the similarity using the WP.similarity function, we see there is a 90% similarity. That means these words can be used in conjunction with each other or they have some relationship. If we try to do cat and dog, and mu, say for that instance, there is a good 90% similarity for them. But if we try to find the similarity between sheep and a bike, that reduces to 70%. They're still coming to 70% because both of them are means of transport. That means there is something. If I would have said transport here, and check the similarity again, you see the similarity increases. That goes to roughly 80%. Right? If I say car and transport, the similarity would be lesser. If I say truck and transport, what do you think? Similarity would increase or decrease? No, that's still the same. All right. Uh, I believe the topic beyond this vectorization of counts. Okay. Vectorization is that if we want to convert any text, whenever we want to work with text, machine learning does not work with numeric, unless and until the data is numeric, machine learning will not be able to work with it. So when we want our system to learn from it, then we have to convert them to a form which is amenable to machine learning. So for that, you can use a count vectorizer or a TF-IDF vectorizer, which are two different operations which have been covered in our book with example that how do you convert uh, text to a vector form. This would be the one which is going to go to your machine learning to learn from. Similarly, for a TF-IDF, this is again a vectorizer that which converts any sentence to an array first and then creates an array which actually gives you the relative weights of the vectors. All right. I hope that because I see no questions on the chat window. Ashish sir, are there any questions on the
Yes,
YouTube?
sir.
Acha,
Yes.
Swati had a question. I am looking at it. Swati says how Gemini has failed. It is a great product from Google and a competitor from Chat GPT. Swati, I wouldn't say Gemini has failed per se. They have different strengths. I'll show you what Gemini can do. Maybe if it is open on my machine. Okay, let's talk to Gemini for a while. Let's give it a different chat. And mind you, we are still working on the NLP part. So this is going beyond. So let us say, so let us say my query goes to, we are trying to work with the heights and handstands for 100 samples. Create a data sheet and visualize it using Python. If you give it same to ChatGPT 3.5, it may not be able to create a data sheet. Okay. And it may not be able to visualize it either. ChatGPT 4, however, would be able to possibly visualize. So see, it can generate data. It gives you a code. It creates a data sheet that you can store it to somewhere. It gives you a built-in function to work with it. It tells you what visualization to use with it. There may be possibly. This might say no to your question. Sometimes you have to prod it, but it works. And the best way how to work with any of these systems is, okay. Sometimes you have to tell them that you can do it. They are more like Hanuman, where they know what their capabilities are. Sometimes they forget. Sometimes you have to prod. What? What? This is going into an entirely different domain. I was too polite to it. It actually gave me an answer irrespective of what the question was. For you, it might be a failure. For some people feel it's a failure. But the good part is, how is it going to monopolize the market later? It is okay. After so many attempts, it still did it. After having said no, after a lot of plotting and prodding, it still did it. And it also gave me the code behind this. All right. So, my point is, Gemini is not a failure per se, but it is too cautious. Cautious to that extent that sometimes it would not even give you an answer to the query which you are asking, for the sake of that. It is actually worried that whenever it is going to answer, it might go outside the boundaries of ethics. So that is the worry that it is working with. So that those guardrails of AI, that chat GPT is saying that, okay, let my answer go anyhow. It might be unethical, it might be biased, it can be anything. I don't care. Google, however, is a company which has to be very, very cautious with this, that whatever it is generating should not be unethical or should not be biased, because it has got a lot of criticism that way. So that is the reason why it is working on a very safe note. Okay, thank you, Swati. That's the answer to this. Any more questions? Anything goes. I mean, I have 3-4 minutes before we conclude. Yes, it has disabled. It has kind of disabled. Oh, it is, sir. It allows, it generates images, but you have to prod it a lot before it does that. But it
Now,
does. Sometimes you have to coerce
right
that
now,
answer out.
I think they have disabled it. I think they are going to bring it back, but for now it is disabled.
I just tried it. It works. And most of the times you just have to be polite to it, tell it you can go slow, give it a query, because when they are trying to work with speed, they often go into the domain of losing accuracy because they want to give a response very fast. But otherwise, when you, for any chat, this would be good for any specific large language model. Allow them to take a breather, allow them to ask that, go slow on the generation, and they work very good. So that's my time. I hope there are no more questions on this session. Thank you so much for having us. Please do review our book and recommend it, because we have taken a lot of time and effort to make it suitable for the teachers out there. All the best. We can close the session.
Thank you, Dr. Gupta, once again for this informative session. I also thank the participants for joining in. We'll soon be back with another session for class 9, and we expect all of you to be there to benefit from the series of sessions we'll be bringing in soon. Thank you. Have a great weekend ahead. Stay safe. Thanks.